This video is on examples of distance formula, midpoint formula, and triangle midsegment theorem. Our first question says to find the distance between coordinates -2, -1, and 3, 2. Round to the nearest hundredth. That means 2 decimal places. So first, I need to know the distance formula. So this is our first way of doing it, is the distance formula. So distance formula was equal to the square root of x sub 2 minus x sub 1, all of that squared, plus, parentheses, y sub 2 minus y sub 1, all of that squared. That's the distance formula. You can also use the Pythagorean theorem. So distance formula is equal to the square root of, so parentheses, x sub 2, I'm going to use 3, minus, then x sub 1 is -2, parentheses squared, plus parentheses, y sub 2, which is 2, minus y sub 1, which is -1, close parentheses, squared. I'm going to simplify this. Distance is equal to the square root of 3 minus a -2, which is really 3 plus 2, which is equal to 5 squared, plus, parentheses, 2 minus a -1, which is really 2 plus 1, becomes 3, parentheses squared. Keep my square root symbol on it all the way. Distance is equal to the square root of, so 5 squared is 25, plus 3 squared is 9. Keep my square root all the way on it. Distance is equal to the square root of 25 plus 9 is 34. So I take the square root of that. The distance is approximately, if I take the square root, 5 and 83/100 units. That is one way of finding the distance. Question 2 says find the length of the line segment containing these 2 points. Length, again, is another word for saying let's find the distance. That's what that means. So we're going to find the distance. I'm going to use a different method instead of the entire distance formula. I'm going to use Pythagorean theorem. So I'm going to go back to knowing what my change in y and my change in x is. So I know my horizontal change and my vertical change. So I'll use a table. So I don't want to graph it. My coordinates are -4, -1, and 0, 2. I need to know my change in y. So my change in y is adding 3. And my change in x is adding 4. So what I'm going to use here is the distance formula with the change in y and the change in x, or Pythagorean theorem now. So I can use distance is equal to the square root of, we're going to have 4 squared plus 3 squared. So in this case, we have distance is equal to the square root of 16 plus 9, which is equal to the square root of 25. The square root of 25 is 5. So our length is equal to 5 units. And that is using, again, the helping us to find the Pythagorean theorem so that we don't actually have to graph it. And then we can plug it into the distance formula, because it is the change in x squared plus the change in y squared. So I did the change in x squared plus the change in y squared. Question 3 says find the midpoint between those 2 points. So midpoint, if we remember, is the average of the x's and the average of the y's. Remember, it is a coordinate. So it's x plus x divided by 2 and y plus y divided by 2. Technically, that would be x sub 1 and x sub 2 and y sub 1 and y sub 2. So find the midpoint. We will take, it will be a coordinate. So our x's are -4 plus, then we have a -2. We're going to divide that by 2, comma. Our y's are 4 plus, then our next y is 2. We're going to divide that by 2. So we have -4 plus -2 is -6. We're going to divide that by 2, comma. 4 plus 2 is just 6. Divide that by 2, comma. And our midpoint, we're going to simplify this, is a coordinate at -6 divided by 2 is -3, comma. +6 divided by +2 is +3, comma. So our midpoint is at negative 3, comma 3. Question 4 says to find the midpoint of these two coordinates. So again, we're going to take our x's, negative 1 plus the 5. We're going to divide by 2, comma, because it's a point. Take our y's, 1 plus our negative 5 is our other y. All that divided by 2, close parentheses. So we have negative 1 plus 5, or 5 minus 1 is a positive 4 divided by 2, comma. 1 plus negative 5, which is 1 minus 5, is negative 4 divided by 2, close parentheses. So our midpoint, once we simplify this, will be 4 divided by 2, again as a coordinate of our x is 2, comma, negative 4 divided by 2 is negative 2, close parentheses. This is our midpoint of our two coordinates. The next question asks us to again find the midpoint, but this time we're given decimals. We do the same thing. We're not going to change our method. So we have parentheses, our x coordinates, comma, our y coordinates. So we have our x's are negative 3.1 or negative 3 1/10 plus 4 and 92 hundredths, all of that divided by 2, comma. Our y's are negative 2 and 8/10 plus negative 3 and 3/10, all of that over 2, close parentheses. So when we add these together, negative 3 and 1/10 plus 4 and 92 hundredths, we get 1 and 82 hundredths, and we're going to divide that by 2, comma. When we add negative 2 and 8/10 plus a negative 3 and 3/10, so that's really negative 2 and 8/10 minus 3 and 8/10, we get negative 6 and 1/10 divided by 2, close parentheses. So our midpoint, when we divide these by 2, we will get 0 and 91 hundredths, comma, negative 3 and 5 hundredths is our midpoint. Decimals, you can still add and subtract, and we can still divide. Next question says that B is the midpoint of AC. So we actually are given the midpoint in this case. We have one coordinate of A, which is 2, 5, and we're given B, which again is the midpoint. Find the coordinate of C. There are a couple of ways you can do this. I like to visualize this. So I know I have coordinate AC. So if I say this is coordinate A, and this is coordinate C, I know I have a line between those. That was not a line. I know that B is directly in the middle. I know the coordinate of A, which is at 2, 5, and I know the coordinate of B, which is at 5, 1. So to find the coordinate of C, I need to know how A is moving to B for both the x's and the y's. And I will do the exact same thing to get to C. So if we look at the x's, I can see that 2 is moving to 5 by adding 3. So I'll do the same thing to get to my next coordinate. So 2 plus 3 is 5, 5 plus 3 is 8. So for my y's, I see that from 5 to 1, I'm subtracting 4. So I'll do the same thing for my y's. So I'll subtract 4. So 5 minus 4 is 1. 1 minus 4 is negative 3. So my coordinate of C is at coordinate 8, negative 3. I do this visually so I can easily see what are happening to the numbers. I have to read carefully to know that B is the midpoint. So I have to make sure I know which letters go where. Now there is another way to do the same type of problem. So B is the midpoint of AC. We're given A and we're given B. So we're given one coordinate and the midpoint. I'm going to show you another way of doing this without doing it visually. We know the formula for midpoint, which is x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. This is actually equal to the coordinate of x of the midpoint, comma, y of the midpoint. So I'm using x sub m and y sub m to represent the midpoint. So I can actually plug my numbers into my formula right here so I can solve for the rest of it. Let's focus on the numbers that we do have. A is negative 6, comma 4. So I have one of the x's and one of the y's. The same one though, so I'll use x sub 1. So I have negative 6 as my x, plus, I don't have my x sub 2, so I'll put x sub 2 divided by 2, comma, I'll use my y value of 4 as my y sub 1, so 4 plus y sub 2 over 2, because I do not have my y sub 2. This is equal to, I do have my x of the midpoint though. So I have my 4 is the x of my midpoint, comma, I do have my y of my midpoint, which was 8. So what I can do is I can take my x part of my midpoint and equal it to the x part of my midpoint, because this is the formula to find this value. So I would take the first part of my parentheses, so negative 6 plus x sub 2 divided by 2 would actually be equal to the 4, because that's the midpoint. That's the x value of the midpoint. And I would then solve. I would multiply by 2 so that I would get rid of this denominator. So I would have negative 6 plus x sub 2 is equal to 8. And then I would add 6 to both sides to get x sub 2 is equal to 14. I'll do the same thing with my y's. I'd have 4 plus y sub 2 divided by 2 is equal to 8. I'll multiply by 2 to get rid of this denominator, so I'd have 4 plus y sub 2 is equal to 16. And then I'll subtract 4 from both sides, so I'll have y sub 2 is equal to 12. Now I have my x sub 2 and my y sub 2, so I can write my coordinate for C. C is at 14, 12. This takes a little bit more work, but it's the algebraic method versus the visual method. You could use either way. Our last question on here is to find the length of line LN. So we want to find this length of LN. This comes back to the triangle midsegment theorem. It states that if we have midpoints, if this segment connects midpoints, so E is in the middle because we have 2 tick marks here, and F is in the middle because we have 2 tick marks on MF and 2 tick marks on FN. Then this segment here is half of the length of the bottom segment. So we can state that the length of EF is equal to half of the length of LN, the third side of the triangle. So we would plug in or substitute our expression for EF, which was x plus 2, is equal to half of the expression of LN, which is x plus 10. I do not want to distribute the 1/2 because I'll still have a fraction. So instead, I'll multiply by the reciprocal on both sides. So when I multiply, I want to multiply all of this. I'll put that in parentheses by the reciprocal of 1/2, which is 2. So I'll actually multiply both sides by 2. When I distribute, I'll get 2 times x, 2x, and 2 times positive 2, which is positive 4, is equal to the 1/2 times the 2 will divide to a 1. So I'll have 1 times x plus 10, which is x plus 10. Now I can solve. I want to get my x's on one side. I have 2x here and 1x here, so I'm going to subtract the 1x from both sides. So since I moved from right to left, I want to take my 4 and move it to the left-hand side. So I'll then subtract 4 on both sides as well. So we'll get 2x minus x is 1x. 4 minus 4 is 0, equals x minus x is 0. 10 minus 4 is 6. So we get x is equal to 6. That is not what the question is asking for, but now that we have x equals 6, we can plug it into our length of Ln. So again, Ln is equal to x plus 10. We can then say that Ln is equal to our value of x was 6 plus 10. So Ln, length Ln, is equal to 16 units. 16 units, because it is a length. We need to make sure we have our numbers on our units. And that is the triangle mid-segment theorem.